Looks like it's working. Perfect. So I will pass over to Professor Sean Smith for the Centre of Future Infrastructure. Thank you, Sean.
Thanks very much, Jenny, and good afternoon, everyone. I hope you can hear me all well, and please feel free to munch lunch, etc. while we're presenting. It's fully understandable as it's a kind of lunchtime seminar. So I'm joined by Professor Lindsay Beavers, and Lindsay is lead and head of the Research Institute for the Institute for Infrastructure and Environment. So I'll go first, just covering a bit about what CFI does and how it interlinks across the university, and then I'll hand over to Lindsay. I'll just share my screen just now. So hopefully you can all see that okay, and we'll put it on presenter mode. Great, well, a very warm welcome. I'm Sean Smith, and I'm Chair of Future Construction in the School of Engineering and also Director of the Centre for Future Infrastructure, which is based on our Edinburgh Futures Institute in the centre of Edinburgh. Today I'm going to cover quite a bit of the kind of work that we do, the diversity of it, and also the significance and the importance of all the work that we do right across the UK universities in infrastructure and resilience. And we consider what's coming down in the pipeline for the future. It's a tremendous and exciting area to be involved with. So we're going to cover areas around the interdisciplinary features of CFI, some of the projects we're doing in the UK, big focus on what's happening on some of the net zero front for buildings that we're involved with, and also touching from a range of projects, whether it's transport, future skills, or also international. As I said, the Centre for Future Infrastructure, or CFI, is based in the Edinburgh Futures Institute, and it is officially fully opening this year, so it'll be wonderful to get in. You're all very welcome. If you're up in Edinburgh or have the chance to come and visit us, please do. And that warm invitation also to visit us at King's Buildings, where Lindsay's based with the School of Engineering. But the main focus of the Edinburgh Futures Institute is to be multi-interdisciplinary in its approach. So the role of CFI is not to generate a brand new sort of batch or cohort of new engineers, of staff. It's actually to link staff across the university, linking engineering and our science domains into all sorts of other areas across the university to create that interdisciplinary approach. The kind of work we're doing is wide-ranging vis-a-vis infrastructure, looking at sustainability and net zero, the interlink with data and the use of data, where we're looking at smart cities and working across the region, or in looking at developing future innovations, whether it's resilience for climate change habitats, systems engineering, etc., and looking at some of the complex issues and real challenges which are coming down the line. But most importantly, our role is to link across many of the other schools, and there are 22 schools across the University of Edinburgh. And already we've had projects which link geosciences, like health, humanities, etc., law, and various others. So a bit about the future. We're going to spend a lot of money globally over the next 20 to 30 years, roughly about $100 trillion in buildings, transport, and infrastructure, a huge and significant sum of money. And again, very much needed when we look at the resilience and infrastructure, both in the UK and overseas, but also when we're looking at societal growth. And this is one of the key features going forward as we approach, the year 2100 and that population growth that's coming. One of the key features we're going to have to deal with is how are we going to build 2 billion new homes in that time period in 80 years? A huge, huge increase in resources and also all the related infrastructure that comes with it. To give you an idea of what that means, taking the 29 countries on the left-hand side that map across Europe, and given that population, what we have to build in the next roughly 75 years is 6.25 Europes all over again globally. Plus all that infrastructure of hospitals, offices, industry, etc. And therefore, of course, we have to be as sustainable as we can. And hence all the projects that CFI is involved with have a very, very strong environmental strand, as do many of the research colleagues both here and across UK universities. I was giving a presentation just back in November, just talking about the timelines, whether it's Scotland or it's UK and Europe's net zero targets, so 2045 and 2050 respectively. And certainly sitting down with civil servants, you tend to find that we're talking about, well, it's 22 years or it's some 27 years away, etc. Well, in fact, we don't have, for example, in Scotland, 192,000 hours. when you take away the weekends and the half Fridays that the construction infrastructure sector is not working, we're down to 111,000 hours of time between November last year and November 2045. And then, of course, we don't work 24 hours a day, so we'll be working, if we're really productive, 8 hours a day, and in a 10-hour day, and hours for travel, an hour in the morning, at night. But literally, we're down to 36,900 hours. Now, on top of that comes all the work to come. In Scotland, we're going to have to retrofit 145,000 homes per year. England's about 910,000 homes per year, and Europe's just short of 12 million. But what's incredibly important is you have 85% of all countries around the world who have signed up to net zero after COP26 in Glasgow. And so we have parallel synergetic demand on very similar material resources and aims, policies and ambitions. So we can't carry on retrofitting as we currently do, of house to house and starting all over again on each house. Could we look at archetypes approaches? And this is one of the features that we've had a big push on, certainly north of the border. We know these kind of things are also being looked at in England and Wales, and also in other countries like Germany and France. And therefore, when we're going to do this kind of testing on specific archetypes to create solutions, there's some specific tests we should all be doing. So we're collating a fantastic database and knowledge exchange point for sharing to accelerate this approach. So by archetypes, for example, in Scotland, we have very old stone tenement buildings, and we have roughly about 240,000 of those. These are all built pre-1919. They're hard to treat. We have 400,000 timber frame buildings in Scotland alone, something like 750,000 in England. And that's a key archetype at which, in terms of looking at retrofit, can we approach it faster, better, and more productive? We produced a report along with all the registered social landlords, it's the housing associations and local authorities in Scotland, in achieving net zero in social housing a few years back. And within that, we published a paper discussing the archetype approach and for mass retrofit. That was then published by Scottish Government, and since then they've issued a tender on that. But in the meantime, everyone else has been cracking on with what they need to do, but it's all very individualistic, and we need to bring that archetype data together. Scotland has a particular issue, just to explain. We have the highest proportion of flats in the UK, roughly about 38%. When you compare with England, which is about 21 to 22%, and Wales is about 13%, and Northern Ireland's about 8-9%. So we have a pretty tough task ahead. In addition to that, the cities of Edinburgh and Glasgow have the highest density of flats in the UK of any city, and they're at 68 and 73%. London's about 46%. So we've been running a series of workshops looking at archetypes. It's been really tremendous. Lots and lots of people have been attending these. And we looked at the domestic buildings, non-domestic, and also looking at conservation of heritage buildings. Beyond that, what we've now done is we've drafted a report, and that will go public very soon, on applying a retrofit low carbon technology archetype approach to buildings in Scotland. But there are many learnings from that that could be taken into England and Wales and also Northern Ireland. In addition to that, we also advise and are brought in to engage in future procurement programmes with public sector. So in this case, Scotland Excel are managing the 800 million retrofit fund looking at energy efficiency on housing in local authorities. It's over 4 years, it's 200 million per year, and they needed to design a contractor's framework approach to that procurement, which made sure that we can embed all the key issues and key factors within the programme as people would be applying for this procurement. So we helped them set up a technical user intelligence group, a technical advisory board, and since it's been launched just over a year and a half ago, it's been a multi-award winning project. The diversity and range of what we do has to happen not just beyond our own cities and towns in Scotland, the UK and internationally, but also what we do in our own doorstep. So we had a new School of Engineering building that was designed back in 2017, 2018. COVID hit, it got delayed. So as a result, under the sort of design in for change, we were asked to review that in 2021 and 2022 to look at, can we actually enhance or improve its approach towards net zero? We've redesigned a lot of components in it, reduced the fabric embodied carbon by about 65%. And in addition to that, we've decided that because there's still some unknowns as to some of the future technologies, what we've done is we've designed in a net zero laboratory. This is on the ground floor adjacent to the plant room. Everything will be wired in, plugged in, water, etc., everything that we would need. We can test some new technologies there, but when the timing is right and the technology is right, we will then make that effectively the engine of the building, and it will power the building. And so we're all ready to wire that up in the future as and when we're ready. So in other words, we're making the building net zero ready. It's not net zero from the outset, but we're making it net zero ready for that transition. Of course, there's been many previous challenges when we look across all our buildings and both our infrastructure. Many of these are shown here. And the issue is kind of what next? And some time ago, we proposed the idea of having a national buildings database. We were delighted to see that the Department of Energy Security and Net Zero then launched a call, a tender for that, which I believe UCL is undertaking. But we were actually working almost in parallel with the thinking that was going on at UK government. We hadn't actually spoken to them, but we're delighted to see this. And we've had a number of meetings and events that we've discussed with people and multi-stakeholders, including the Health and Safety Executive. And the primary users of this are many and multi in their diversity of who and what could use a national buildings database. It seems strange in this day and age that we don't have that database ready to hand, or there isn't that data kicking around and available across existing databases. But if we could have this, then we could really make a huge step change in how we approach not only retrofit, but also how we approach circular economy for future buildings when they come to end of life, if they're not going to be reused. Also how we can look at safety and other features and avoid hunting for different building issues as they arise, because we'd have a database that would have a lot of the information across the UK. In terms of net zero, our colleague Julio Bros Williamson, who's our Chancellor's Fellow in Net Zero Buildings, is leading on one of the largest net zero developments in the UK. This is based in Edinburgh. It's down at the Granton waterfront, and it's a fantastic project looking at a whole stream of different activities, not just net zero and energy performance, but it's off-site construction, digital approaches, future monitoring, etc., etc. And this first test site will be the one of then a phase of 1,000 net zero homes, and there's further phases to come. Another 10,000 homes are planned along the waterfront there. So a great opportunity to create impact and drive the whole net zero agenda. When we look at infrastructure, we kind of like to consider that, well, we're quite lucky. We've got lots of petrol stations for travel and everything else, but of course we're going to get rid of petrol and diesel. And currently, when you're looking at the distance routes across the likes of Scotland, Scotland has 38% of the UK, 38% of the UK landmass, 8.5% of the population. So we're quite spread out. But in addition to that, we've got long distance journeys for everything from our whiskey that's transported to the fish and salmon, etc. in the northwest, to the tourism, which goes on right across the Highlands and Islands. And so currently, when you consider where we need to go in terms of whether it's hydrogen for long range truck and delivery vehicles, or even for intercity vans, and Perth is quite a unique place because it interlinks the 7 cities of Scotland at a key junction just on the outside of Perth. So we've been working with Perth West, which was then evaluating the potential for infrastructure for a transport hub there for hydrogen, and also to look at future accelerated rapid EV charging. And on the back of that, the investment of £118 million is going ahead. There'll be 1,200 temporary jobs and 1,000 permanent jobs. Most importantly, that one road between Perth West and Inverness in the top right carries 80% of Scotland's whiskey, and that gives the UK Treasury roughly about £6 billion a year in excise duty. So it's quite an important transport corridor. We've also been involved with a number of reports, including a circularity gap report. You may have seen these before. A number of countries and also cities have undertaken this approach using a common methodology. And we were on the advisory group looking at this. And this is Scotland's kind of circularity gap report of what are we extracting, what are we importing, what are we using on the right for societal needs, and what are we exporting. And that big area of sort of blue, pink, light blue at the bottom, that big long, almost like pipeline, that's the oil and gas sector in Scotland from the North Sea. So you can see in that sort of blue line just how little is going horizontal into the local needs. The rest of it is generally all for export. Now, globally, circularity is roughly about 8 or 9%. We're reusing about 8 or 9% of things that we're consuming. However, Norway, their circularity is 4%, and in Scotland, it was even worse, it was only 2%. This is because we're so heavily reliant when you consider materials for clothing, materials for other areas such as plasterboard. We import that predominantly or over the border from England or from Europe because we don't have our own plasterboard plants. So effectively, we are consuming a huge amount of resources that we're needing to bring into the country, and it's creating effectively this gap and very, very low circularity. Looking ahead, there's some new technologies coming, and we've been working with, this is a British company based down in England, Heatwave, which is an RF frequency microwave heating system, which is looking very exciting. When you think about a air source heat pump, it takes roughly about 4 days to install, plus everything else that has to go with it. This is a half-day install. You don't need to change your radiators, you don't need to change anything else. It's a plug and play with all your existing works. It's roughly the same size as a boiler. So the world's first trials will commence this year. We're very excited about that and a great opportunity to explore its operation, particularly for flats where there are many limitations on the use of heat pumps and other issues, or there's not space for water tanks. Looking ahead, we have to consider also this workforce. Now, some years ago, I was involved with the Edinburgh South East Scotland City Region deal, and we were looking at what's to come. And Edinburgh is, in the southeast of Scotland, is the fastest growing region in Scotland. It's the 5th fastest growing region in the UK. And you consider the amount of housing and infrastructure that needs to come, we really needed to scale up what we were going to have to do to deliver at the scale of, for not only for retrofit, but also for new build. And the top right diagram shows the relationship of the workforce in 2023 across the various 7 regions of Scotland, as we describe them as regional areas. And you can see the southeast on the left-hand side has the highest workforce requirement at 57,750. Now, 7 years ago, it was Glasgow in the west that was the highest. But we know that the southeast is going to rapidly expand even further. And so we're working with the local colleges and the other universities, such as Heriot-Watt and Napier University, who are involved in infrastructure and built environment, to try and make sure that we can get as quickly as possible that accelerated workforce. And that's going to be a tough task. We've also assessed what is the gap analysis that we're going to require and the lack of take-up that's going to happen on an adoption of some of the low-carbon heating systems without this increased workforce. Internationally, just some examples here of some of the projects we're doing. We've been working with Cornell recently under a joint knowledge exchange fund with the infrastructure policy unit there, which has been very exciting. And we'll do some cooperative work over the coming year. We worked with the Italian government over 2 years in Milan, looking at the ETC, which is the Institute for Technology and Construction of the Italian government, looking at net zero transition and technical compatibility factors for infrastructure. We currently have a project with Dubai, and that's looking at a sustainable regeneration of part of Dubai. And the Galapagos Islands is multi and interdisciplinary with colleagues across the university from architecture, planning, law, health, biological sciences, geosciences, and engineering, supporting the Galapagos Islands in this transition of where they need to go with net zero. So I want to finish off just about there, but just to say again, if you're coming up to Edinburgh, please let us know. If you'd like to pop in and see us, please do so. And it'd be great to welcome you in our new home at the Edinburgh Futures Institute when it opens in a few months' time. So I'll just stop sharing and I'll pass over to Lindsay, who's now going to cover more of the specific work that we undertake within the School of Engineering through the Institute for Infrastructure and Environment.
Thanks, Sean. And yes, and thank you very much for having me here today. I've got a slideshow, which I'll show you in a second. I'll start sharing. But I just wanted to say, first of all, I am an environmental engineer, a civil engineer by background. But as Sean mentioned, I'm the head of the Research Institute for Infrastructure and Environment. And that means I am the research lead for the team here that is about 35 academics, and that covers a wide range. And I'll take you through some of the kind of exciting projects that we're working on right now and give you a bit of a whistle-stop tour of what's going on here. So I'll just share my screen and then go into presenter. Now, can everybody see that? I'm hoping that that's a yes.
Yeah, we can see it. Thanks, Lindsay.
Brilliant. Thanks, Sean. Okay, so I'm going to take you through a little bit of what we do for within the Infrastructure and Environment Institute. What you've seen with what Sean's given you a flavour for is some of the future infrastructure work that goes on, and that fits within a theme within our institute. So this institute is one of 7 across the School of Engineering, and within that we are predominantly focused on looking at different technologies for efficient, sustainable and resilient infrastructure in both the built and the natural environments. I like to include the natural environment because that's very much where I sit. And it builds on that future challenge that Sean was talking about earlier, future infrastructure and what we're going to need in order to deal with the climate emergency and adapt and mitigate the coming climate emergency. So we have a number of themes where our applications go across from smart cities right through to the built environment, transport, and energy and water. So we have 5 themes within our institute with the 35 academics: environmental engineering, fire safety engineering, granular mechanics and geomechanical processes, infrastructure sensing and systems, as well as structural engineering. So you can see it's a broad gamut across the whole of the civil engineering spectrum. So I'm going to pick on a few particular projects from each of these 5 themes and talk you through them a little bit. So the one that's closest to my heart is obviously environmental engineering, and I'll take you through that theme first. We have a number of different funders going from NERC through to EPSRC. The first project that I wanted to highlight here is some work that we're doing with the University of Stirling, building on the River Forth Environmental Resilience Array, which is a highly instrumented catchments within the Forth estuary, looking at both water quality and water quantity. And this project, which is MOT for rivers, monitoring, modelling and mitigating pollution impacts in a changing world, is part of the NERC Freshwater Quality Programme, where we're looking at the emerging chemicals and how emerging chemicals and pollutants are moving through our system and how climate change may be influencing that, in order that we can understand this better and then think about how we might adapt and mitigate this in the future. So it's bringing together state-of-the-art science. This is coming predominantly from the Stirling Group, where they have cutting-edge sensing equipment that they've got, as well as the next generation satellite assessments, along with the University of Glasgow bringing machine learning and advanced statistical assessment to the problem. At the University of Edinburgh, we're responsible for the hydrological modelling and understanding the role, the movement of the pollutant chemicals through the catchment. So it's really interesting. It's only in its first year, so we've got a long way to go, and it's a very interesting project, bringing together a number of different actors. In fact, just along the corridor is the first meeting of this programme grant. This one, COTIDE, is also a very interesting project. It's funded by EPSRC. It is a programme grant led by the University of Oxford, looking at tidal energy stream and how we can maximise the and scale up the opportunity of tidal stream energy. Here in the University of Edinburgh, we're responsible for a number of things. What I'm focusing on here is the hydrodynamic modelling and the coastal modelling that the University of Edinburgh within the environmental engineering theme brings. On one of our other sites out at Maxblade, we are looking at the composites and how different composites can be used within the turbine construction. That all comes together with the university that's being led by the University of Oxford, and it also includes the University of Strathclyde. Another programme grant, this time led by the University of Glasgow, is looking at bringing together off-grid water and wastewater biological treatment systems to understand a better way to deliver water to households. So it's led by the, as I said, led by the University of Glasgow, but it involves the University of Edinburgh looking at different membrane technology that are both affordable and low energy, so that we can provide off-grid solutions to particular householders. If we then move on, I find this, I won't leave this video running for too long because it's quite mesmerizing, I find, but one of the real things that the University of Edinburgh is known for is also fire safety engineering, and we have a very strong fire safety engineering group. They're heavily involved in looking at the Grenfell Tower inquiry, as well as a number of recent projects looking at fire spread in timber ceilings. Now, I think this is worth highlighting because some of the things that Sean was talking about, retrofit and looking at timber frame buildings, we also have these associated issues where we've got to start looking at what is the implication then if we start using more timber in terms of fire hazards. So there's a number of projects EPSRC funded, but as well as HSC funded on the hazard posed in tunnels, for example, by the increased use of hydrogen. So what are the knock-on implications of the considerations that we're having to, and the adaptation that we're doing as a result of moving towards net zero? There's also, within the fire safety engineering component, there's also considerations on safety. So we need to think about safety for firefighters, and in terms of the research that goes on here has helped to define safer procedures to inform the fire brigade guidance and how people work in confined spaces or within emergency situations. So that's working very strongly with stakeholders such as the Fire Service Research, as well as Scottish Fire and Rescue Service. Another of our 5 themes is infrastructure, sensing and systems. And there's a lot of interesting work going on here, looking at how we can actually assess for damage within infrastructure without actually breaking it or getting inside. So this is using 3D acoustic wave sensing, whereby they've looked at assessing this structure. See if I can use my pointer, this structure here, and then using the sensing to check after the improvements have been made to see that this is indeed done what it was hoped, what the purpose of it was. So can we use this to check what's going on inside? The other, as well as acoustic monitoring, we also use ground penetrating radar. And this is some work that's undertaken by one of my colleagues, Antonis, who is developing open source software, which in collaboration with Google and the EU cost action, in order to make this software available so that other people can use this wherever they're working in the world. And here you can see their webpage if you're interested. They've just got some more funding from Google in order to do some more work advancing this software. Moving on, we also have colleagues who work quite closely with Sean, looking at how we can use these monitoring techniques to assess historical infrastructure. And this is working, for example, with the Historic Environment Scotland, and then being able to use and build these models in order to build digital twins. Now, this digital twin project here, Cognito, is funded through EC Horizon 2020, but it's looking at bringing together data with models in order to build a digital twin of the construction project delivery phase. Moving on to the granular mechanics and geomechanical processes group, we have quite a range within this group, going from both very fine particle DEM simulation modeling approaches, looking at how we can model complex particle systems using DEM, through to more research that aligns more with our infrastructure colleagues, looking at earth and turf buildings and the historical aspects of that. So can we use vernacular materials in order to deliver low carbon, low impact construction? And can we bring that from the past to the future? And that's funded by funders such as the Leverhulme Trust, and again in partnership with Historic Environment Scotland. And then we have a large group working in structural engineering, which work very closely with Sean and the group that he's working in, where we look at innovative materials and innovative design approaches that allows less labour and less steel material to be used when we're installing particular structures, and that can reduce construction time and reduce costs. We also have a colleague, Dr. Marcelo Diaz, who's looking at metamaterials, and that's where we're starting to bring in both the mechanics but also the geometry of materials in order to understand if the equilibrium states within materials, and whether we can use that information and use that understanding in order to better understand how things collapse or how they reorganize when they do collapse within matrices. And that's an ongoing project, an EPSRC Open Fellowship. And then finally, I think it's a really interesting project that is just finished, and the team are actually in the process. In fact, they've just submitted for another grant, which is a interdisciplinary grant to UKRI. But this works on some work that they've been doing in Madagascar, working with the International Red Cross. It's an interdisciplinary team of engineers with climatologists and social sciences, predominantly in Madagascar. They have also done some work in Kenya. And here they're doing experimental testing in the field, trying to work out how they can build structures, and I'll move on to the next slide. These structures, the wiki house structures, which allow you to bring together timber-based buildings that then can be put together by non-specialists on site quickly and with low costs. And the new work that they're looking to get funded is to understand how these wiki houses how resilient these houses will be to future climate, particularly in cyclone prone areas. And so can we test these structures? Can we test the connections within these structures in these cyclone induced areas in order to ensure their resilience moving forward? So I think what you can see from these slides is this kind of consistent thread that works all the way through from environmental engineering through to our structural engineering, of bringing together research under the theme of responding to the climate emergency. And I hope you can see, I'm going to end that show there, And I will stop sharing. And I hope that you can see from that a bit of a flavour of the work that we're doing in Edinburgh and how that links quite closely to what's going on in the Centre for Future Infrastructure with Sean.
So I wonder if this is the point, Jenny, when we could take any questions that people have or any points they want to discuss.
Yes, absolutely. Thank you very much for your presentations. They were both really very interesting, and there's an awful lot of stuff that's kind of going on up there. So yeah, I'll open the floor to everybody that's here. If there's any questions or comments that you wanted to raise, I'll have a. If there's nothing being recorded in the chat. So yeah, open to the floor.
Well, I couldn't possibly let them get away with some questions.
Thank you, Chris.
No, that was fascinating. Really very broad indeed. So one question around the retrofitting. Have you teamed up with, or are you using robotics then to attempt to bring some sort of standard process of retrofitting to some of your buildings?
We haven't directly, but we know that robotics has been looked at. I mean, for example, for the underfloor heating and the underfloor insulation, etc. Although there are some issues with some of the robotic solutions which are currently out there for using sprays. For some of our older stock, it's going to be a bit more difficult with some of the areas of robotics we'd like to use. But I think for some of the more modern stock, there could be opportunities. Where we do think there's great scope is in offsite, in prefabricated systems. We have a test building at the moment, or test buildings down in a tiny village called Beatic, which is, by its name, it's in the back of Beyond, and it's down in Dumfriesshire borders, not very far from the English border. And what's happening there is they've got some funding from Scottish Government. It's a housing association, and they are replacing and are retrofitting timber frame homes, and that's a huge chunk for us. So they're trialing different systems. And one of them actually is because the outer wall in a timber frame building is generally non-load bearing, the outer leaf. So one of the solutions is actually to strip down the external wall, maybe recycle materials, etc., but use then a prefabricated system that would then go on to that. So this is the initial trial. At the moment, it's not going fully prefabricated for the new external envelope, but we think that's the second stage. Let's test this first, see how it's gone. If that looks successful, then could you then, if you were doing whole streetscapes, and because of now with LiDAR and all sorts of digital cameras, you could actually be processing a lot of that information straight back to the factory, and it could be then churning out the new external panels, which could be prefabricated. So I think prefabrication, offsite construction, more than robotics at the moment for the retrofit.
Right, good. Yeah, great, thank you. What I was trying to do, of course, was piece together your need for trained people and the benefits that automation might bring. It's a pretty big issue.
It's a huge issue for the whole, for everyone, many countries, huge issue. But yeah, good point, Chris, good point.
Yeah. Okay, good. I see another hand's gone up. Good, so I can be quiet.
Hamid, thank you.
Good afternoon, everyone. Thank you, Lindsay and Sean, for really interesting presentations. I've got more of a general question. I mean, the construction industry is quite notorious for being resistant to change and new information. I know the use of the RAAC concrete was a bit of a departure from what the construction industry like to do. And organizations like National Highways, etc. Generally, when you're introducing a new product or a new way of doing something, you have to jump through a lot of hoops to get it approved. So I'm just wondering, what's your approach for trying to get buy-in from organizations for the new methods that that fall out of the research you do? So new materials, new ways of doing things, etc.
Shall I go first, Lindsay? I think one of the points is it's getting that trust and confidence in something. And we've seen in the latter years, recently, the huge push for cross-laminated timber. And yes, it's been used in Austria. Yes, it's been used in Germany. But it's also had some limitations on its use. And when we then have let's say, a very biased, one-sided view of we should be using some material regardless, when people who are wanting to de-risk to help its growth start to state, well, hang on, what about moisture penetration? What about this? What about that? And it doesn't get dealt with properly, that then opens up another RAC issue. And so what we've got to do is have trust and confidence that when we're bringing something to market, we have been holistic in all our senses as engineers, as designers, as innovators, as researchers. We have asked the hard questions, and we have to do that before you get in front of people that you're trying to convince. Now, if you can convince them on cost and productivity, this is going to work, that's a good step. If it's just environmental and there's no stick for that environmental, then the issue is that it's going to be a bit tougher. But I'll pass over to Lindsay, because I know that that's part of the issue with the fire sector here, the fire group. They're involved in a lot of that kind of thing.
So, I mean, I think Sean hit on exactly the right way I would be putting it. I think it's about building trust, and it's working in partnership, and that's something that the fire group absolutely do. They're working in partnership with the stakeholders, and they become they work very closely with them to develop materials. I think if I can talk a little bit from the environmental side, for example, while I don't develop new materials, for me it's very much about working with the stakeholder to co-design the research that is required such that you can deal with the issue that they're facing. You're so right. Across civil engineering, for me, it's the water sector, really, really risk averse. And the only way to change that risk averse nature is to work with those that are dealing with it in order to properly understand the problem, co-design the research that takes them along with it in order to break down those barriers to allow us to move towards, because I think we've got a real challenge ahead with the digital transformation, for example, and how can we use all of the data that we have out there and how can we make that as useful as possible, and that requires working with our stakeholders to show what that potential is. I'm going to stop there because I can see more questions.
Yeah, I would just say that there's another thing there, and it might chime with Christopher in his area of work at Birmingham. We know that many of the city authorities, not just in Scotland, across the UK, are going to look at community and district heating, particularly for flatted and dense streetscapes. And as soon as you mention community district heating as a retrofit measure into an existing streetscape, costs spiral, uncharted services, etc. And so coming to risk, if you approach some of the water authorities, now we're fortunate, the water authority is still a public body up here, doesn't make them any less risk averse than a private sector company down south. But what's important is in many of these large streetscapes, there's some enormous sewers or water treatment pipeworks, which are barely, if ever, full. And so the idea being that you, instead of digging up the streets, could we actually be putting in some innovative pipework at the top circumference of the existing large wastewater treatment pipes, sewage pipes, which are in various streetscapes, which could, one, accelerate community district heating, incredibly reduced cost, and you're probably going to take up maybe 5 or 6% of that cross-section layer of the pipe because you're threading a new pipe through it, a smaller one. But when you approach some of these organizations, they're very risk averse, they don't want to do it. And you can understand that. But at the same time, if we're really in a climate emergency and we've really got to get to where we need to go, then we really need to think a bit more outside the box and how could we design or reduce that risk, that risk aversion, and still deliver where we need to go.
Thank you.
Yes. Would you like to ask your question, Dr. Fager? You're currently on mute.
Sorry. Okay, my name's Dr. Fiona Lesniewska, and I'm based at the University of Surrey. And the past couple of years, I've been working on UKRI funded interdisciplinary circular economy projects, working on mineral-based construction materials. And so I work from a perspective of law and policy. And I'm really struck by, I mean, the ambition of the Future Centre to bring together all the different areas of science, obviously sort of materials, different areas of engineering, but all the levels of government that you'll need to deal with, business, private law, public law, planning. And I've been struck in my own work of the lack of understanding and engagement and ability to really communicate, to move forward on the legal and standards dimensions of a lot of these challenges collectively. And it's always, my experience, it's always been seen that the law and regulation is seen as an aside that can be plugged in at the end. And as a legal scholar, I mean, I know that's just not the case. The discussions need to begin at the beginning and we work together. And my experience has been that people working in science and engineering, digital technologies, everything, they think about the regulatory bit later, you know. And so I think that's a real problem, particularly with Sean's outline of the number of days that you actually have to deliver.
Yeah, it's a very good point. The area that I'm most concerned about just now, if I can throw out all these, you know, things I worry about and have sleepless nights over, is that currently, for example, people are putting in all sorts of battery systems in their homes. So they're collecting PV power or whatever, EV power as photovoltaic power, and then putting it into a battery system. And the building regulations aren't keeping pace with the technology of deployment and what people need. And I've been speaking to some of my neighbours where I live, and I've seen some of them, oh, I put it in this battery system. I go, where did you put it? I put it in the roof. And I asked someone else, where did you put it? I put it in the cupboard, and the cupboard is right next door to where their gas system is. You know, yeah. And all these buildings are designed in such a way for normal fires. They weren't designed for a fire that within 2 minutes is at 600 degrees, if these batteries then ignite. I think in the law side, one thing that's good to see, although sadly it's taken groundfall, is the Building Safety Act coming out has made a lot of designers and engineers, although they're still focused on that area, but it's made them think about it right up front at design stage. Actually, so much so that some engineers and others will not give warranty or indemnity on some of the aspects of a building. And you may have seen that some of the gypsum companies have removed all the usual categorization of half-hour, 1 hour, 2 hour fire resistance that were in their catalogues. That's all gone. It's no longer there because it seemed to be design guidance amongst many other things, or it was tested under a previous standard. I worked in Germany for a while, and for the Italian government and in Canada, for their government research laboratories who work with their national standards bodies. And Germany is phenomenal at this. So, for example, 1 in 3 of all CEN standards, all European standards, comes from Germany. It's started by a DIN standard. And so their national research laboratories work very, very closely with the standards bodies. And 1 in 5 of all ISOs comes from Germany. So I would like to see us be a bit more proactive in the UK of how can we facilitate or preempt and see and lead into and lead on some of these new standards for some of the new technologies or new systems. Because in the back of that, Germany's manufacturing has grown tremendously over the last 40 years on the back of standards. So we should actually get people to consider standards as this is a positive thing in the regulations and guidance, because it can actually underpin a whole new sector. But I'd very much like that all designers and all engineers would consider the aspects of the guidance, statutory duties and everything far more upfront than they currently do. But I'm pleased that the Building Safety Act has started to amend that. Just on that final note, by the way, we talk about laws and bills. We have a circular economy bill coming through Scotland.
I was actually on the a witness in the Parliament for that, and I brought up a lot about the construction sector because
it's not included. It's
not,
like
well,
an
it's
own
not.
goal.
Yeah.
It's the biggest
Mind
sector.
you, the Scottish Architecture Association, their main concern is about insurance for use of secondary materials. And disassembly, etc. So,
although the UK is pretty good, it's the highest recycler of aggregates in Europe and has been since about 2007. So we don't trumpet that very much.
Well, we can talk about that.
Okay.
Maybe I'll get in touch. Right.
Chris, you have another question? Yeah.
So 2 points really. On the last one, we've put together a theory of change for infrastructure in cities that's now published out of UKCRIC. And it's following up on the work that I've been doing for very many years on sustainability, resilience, livability, all things cities and infrastructure. But the point behind that is that there are all sorts of strands, and one of those strands is governance. And we're playing this out now with a current programme grant where we're looking at swarms of small robots that go into pipe to assess the condition of the pipes, particularly sewer pipes. But if you don't get the regulation bit right, in fact, you don't get the alignment with all forms of governance, whether it's formal forms of governance or informal forms of governance, then what we could create would be absolutely super, but can never be used. And so bringing in that idea that we need to align our designs with the forms of governance right from the very start is critical. Aligning also with what I call the business models that sit alongside any innovation. And by that, I mean looking at all of the outcomes, whether positive or negative, and balancing those, and then making sure that our designs achieve their intended benefits by aligning with the forms of governance. So the governance thing is critical, is recognized. Maybe what I should do, Jenny, if I send you a copy of the little book, which I think you may well have already, but if I send you an electronic copy, you could circulate it to people so that you can see just how governance plays out in that. You mentioned sewers, and I had to come back on that, of course. So yeah, but buried infrastructure. I mean, one of the issues around doing things in sewers is how we currently maintain the sewers. So whatever needs to go in there has to be robust against the maintenance regimes. Jetting, of course, to clear blockages is one of or high pressure water jetting to clear blockages is one of the issues, not quite such a problem necessarily. But of course, sewers also host roots from trees. Tree root penetration is pervasive, and the only way of getting rid of those is to root cut. And so what we would need to do before we embarked on that is, I think, two things. One is to understand fully the condition of the host pipe before we started, to make sure that some form of maintenance regime would make it sufficiently robust internally to allow the addition. And then, of course, you would think that I'd say this, but also understand the ground around. Because a sewer is a soil structure interaction challenge, and understanding the ground, the situation around it, the ground, and ensuring that the ground is suitably stable, if you wish, or if necessary, treated in such a way so that the soil structure works synergistically. Then you could start to use the space inside more cleverly, perhaps. And then the last point is, I'm heartily delighted that you're stripping timber frames from the outside of buildings. But if you look at my house, I wouldn't want you to come in because if you took the timber frame away, there'd be nothing left. It's built in 1620, and it's we own a semi. It's the first part of the house. We haven't got the parlour wing at the end, just in case you think I had an enormous mansion. But yeah, well, stripping out timber frame maybe.
Chris, these are our boring timber frame ones, where it's masonry or blockwork on the outside. You don't actually see the wonderful timber that you have there. And just on that note of governance, yeah, this is a major issue now facing utility companies. So you may have heard of this issue, but just in case you hadn't. So when you're looking at either community district heating or in blocks of flats, multiple different flats, multiple occupancy, multiple tenures, which we're all aware of, one of the key issues the utility companies are facing now is, let's take electricity. All the way down the street, utility companies are responsible, predominantly. It gets up to the box at the bottom of the staircase, of the public common staircase of the block of flats. That box is theirs, that's the utility. But from that box, as it goes up to all the flats, it's not theirs. And actually it belongs to the cooperative of all the people in that block of flats. Now, no one ever in a block of flats has ever really, unless there's been a fire, has had to do anything with the cable that comes from the box to their flat. But now if you're looking at, well, what kind of heat systems are you going to have? What kind of heat networks? How it's going to be powered, etc. If you're doing whole streetscapes, that's a concern. And so they're needing some sort of common law or common approach of how residents in these blocks of flats and owners of the blocks of flats can take collective ownership and then decision making and governance over what's going to happen. And it's a real block now, excuse the pun, on how they will adapt all that cabling for the changes to come.
That's right. And the same thing happens when we start talking about multi-utility tunnels. And it's the ownership and governance issues around multi-utility tunnels that typically prevent their implementation. But if we could, on new sites, then look at some form of multi-utility conduit, with most things being co-located and certain things possibly not, for reasons that you've already pointed out, then things could be far more efficient. But somebody needs to take ownership of that, and in the regime that we currently have with our multiply privatized utility service providers, it doesn't lend itself well. If we have nationalized providers, of course, then that might be feasible. Okay, thanks.
Well, thank you very much. There aren't any questions in the chat, so I was just like to say thank you to everybody who's attended, and thank you very much to Sean Smith and Lindsay Beavers for their really interesting presentations. We hope everybody has enjoyed those. There will be another UKCRIC webinar middle of next March, where Tassos will be coming to talk to us about resilience in earthquakes, and some of the work that he's been doing in Nepal and other kind of third world countries with the kind of the building and the kind of resilience to that. So that could be our next very interesting talk. So we look forward to that. Thank you very much, everybody, and have a good rest of your day.
Yeah, great. Thanks.
Thank you.
Thanks. Bye.